We'll start by looking at the two basic progressions, the arithmetic progression and the geometric progression. Looking at the arithmetic progression first, we have the general term un equals to a plus n minus 1d, where a is the first term and d is the common difference. The summation of n terms, so Sn, or if you use sigma notation, a plus r minus 1d from r equals 1 to n will simply give us n over 2 times 2a plus n minus 1d, or simply n over 2 times a plus l, where l is the last term, and n over 2 is the number of pairs, and 2a plus n minus 1d, or a plus l, is the sum of the first and last term. To prove an arithmetic progression, because it differs by a common difference d, just take two generic consecutive terms, so un plus 1 minus un, to give us a constant k. It must be a constant, not a function of n. To find un with Sn, you just need to take Sn minus Sn minus 1 to give us the term un. In our geometric progression, general term un equals to a times r power n minus 1, where a is the first term and r is the common ratio. Sn, the summation, again, of n terms, you can use your sigma notation as well, is simply first term a times 1 minus r power n over 1 minus r, and then you can just do some fractions to give us r power n minus 1 and r minus 1, where n is the number of terms, alright? To prove a GP, now our consecutive terms are now a multiple of each other by a common ratio r, therefore just take the division of two consecutive terms to give us 1 over k, or k, and this must not be a function of n. To find un from Sn, same thing, Sn minus 1 to give us un. Moving on to our sums to infinity, we have the following idea. If Gn is a summation of n terms, there will be a sum to infinity when Gn approaches a value as n approaches infinity. Therefore, lim n approaches infinity of Gn would be a certain value. So some examples include Fn over Gn plus Hn, where Fgr a proper algebraic fraction, or r power n when mod r is less than 1. So if you look at our GP, right, S to infinity would exist when mod r less than 1, or r between minus 1 and 1, with the idea that if you look at our formula for Sn, it has 1 minus r power n. If mod r is less than 1, Rn approaches 0 as n approaches infinity, therefore our sum to infinity is simply a over 1 minus r. Looking at our sigma notation, there are following ideas. If we have summation of r equals 1 to n, and they give us Gn, if you just replace the top variable by 2n, it will give us g bracket 2n, replacing every n with 2n. And the same idea, same summation, but if we increase the variable of the function by 1, we have to decrease the limits by 1. If we decrease the variable by 1, we have to increase both limits by 1. Last idea, which is the method of difference, if you have fr minus 1, or fr plus 1 minus fr. In fact, you can just have any generic function, just as long as a minus sign. The idea is the method of difference, either cancelling upwards or cancelling downwards. Continuing for sigma notation, we have the following ideas. If the summation is from r equals to 2 to n, is basically the summation of r equals to 1 to n minus the first term. Always check the lower limit of a sigma notation when it comes to applying previous results. Alright. Another idea is that if you're adding r equals 1 to n on the constant a, is simply adding a n times, therefore a times n. Last idea, if you want to find the summation of powers of odd numbers, you can use 2r plus minus 1 to the power of k, and that is an important idea that you need to know. Next up, we are looking at the combination of AP and GP change questions that is actually quite common in the exam. Now, in the H2 math method, you just need to find some patterns, right? Basically, you get a generic term of a GP, and sometimes, actually most of the times, the summation of another geometric progression, and the ideas you don't expand. The H2FM method, which is basically the recurrence relation method, and I highly recommend this method because it's very intuitive. So for example, if we have un equals to 0.9 times un minus 1 plus 500, and then we have our first term being u0 equals to 600, we're simply contour expanding by substituting un minus 1 to give us 0.9 squared, un minus 2 plus 0.9, 500 plus 500, and notice that the power of 0.9 is the same as the number you're minusing un from. And then on the right, you have the number of terms, which is corresponding to the power. Therefore, if you're given u0, you have to expand to u0, giving us 0.9 power n, u0 plus 500 bracket 1 minus 0.9 power n, which is the number of terms, over 1 minus 0.9. If you expand to u1, it's just basically 0.9 power n minus 1, and the number of terms is now n minus 1, therefore power n minus 1 in our summation of our geometric progression. So the first line is to expand to u0, and the second line is expanded to u1.